All right, we're getting into loans, and we're going to kind of focus on mortgages here in this video. So a mortgage is basically a home loan. Forgot the O. So that's what we're going to deal with. Roger has found a home to purchase for $150,900. He's agreed to pay 20% down. Now, the down payment reduces the cost of the mortgage, so ultimately it will save you money overall because you're going to pay less interest. So let's figure out Roger's down payment. So he's going to pay 20% of $115,900. And of means multiplied, 20% is 0.2. So 0.2 times 115.9 gives us a down payment of $23,180. So that's what he's going to pay up front. He's going to borrow the rest from the bank. So how much will he actually borrow? What's his mortgage amount? Well, the house total is $115,900. He's paying $23,180. So the difference between that is what he's going to borrow, $92,720. Okay, so if you wanted to figure out the mortgage payment based off that by hand, it's very, very complicated. So we're going to use Excel. And if you have Excel on your computer, it might be nice to pause and try this stuff out as you go, just to kind of see how to plug it in. So Roger is going to borrow this money at a 3.75% interest rate, and he's going to do a 20-year mortgage. Mortgages can be 10, 15, 20, or 30 years generally. I think 15 and 30 are probably the most common, but you can get 10 and 20 also. So Excel is definitely the easiest way to find the monthly payment, and this is kind of the overall formula. So if you're trying to find the payment, it starts with PMT, and this is how you'll type it in, equals PMT, parenthesis. Now we want the monthly interest rate. Well, for Roger, we have an annual interest rate. So if I change that percent to a decimal, and that's annual, to change it to monthly, I divide by 12, right? Because anything that's annual, if you divide it by 12, it becomes a month. Number of payments. Well, he's making 12 payments a year, because there's 12 months in a year, times the 20 years in the mortgage. Now, you can actually work these out if you'd like. But this is kind of the process. And then the last piece is the amount of the mortgage. And we know from the previous page that he's borrowing $92,720. Now notice, that last number has no comma in it. No matter how big it is, do not put a comma. Because you see that these commas here, they separate the pieces of the formula. So a comma in Excel represents new chunk for formula. So you want to stay away from commas inside numbers. Okay, so that's what you would punch into Excel. So the monthly interest rate was found by taking the annual interest rate dividing by 12, and the number of payments was found by taking payments in a year multiplied by how many years in the mortgage. And then we already showed that Excel formula. Now, if you type that into Excel exactly like we showed here, if you type this exactly the way you see it into Excel, it's going to spit out $549.73. That means that is Roger's monthly payment. He'll have to pay that every month, and if he does that for 30 years, he will pay off his mortgage. Now, let's deal with some questions with that. If Roger's monthly payment is $549.73, how much will he pay in mortgage payments every year? So he's paying $549.73 every month. 12 months in a year. So if he pays that every month for 12 months, in 1 year, he will pay $6,596.76 towards his mortgage. And how much will he pay over 20 years? Well, if he pays $6,596.76 a year for 20 years, he's going to end up paying $131,935.20. Now, you could have, from this answer for number 6, you could have started with $549.73 per month, 12 months in the mortgage, 20 years in the mortgage, and that would have given you the exact same answer. Okay? So Roger did not borrow that much, but he's paying back that much. So the difference between what is paid back, so paid back for Roger was the $131,935.20. If you take away what was borrowed, And we know that Roger borrowed $92,720. The difference is the interest. So when you subtract those, you get $39,215.20. So this is why banks love to loan money for people to buy houses, because while you're paying this back, they're earning $39,215. That's for every person who has a house. I mean, that's crazy. And not everybody has a low interest rate. 3.75 is a pretty low interest rate. Higher interest rates means they're paying back more. It's just crazy. Okay, number 8. What is the ratio of what Roger pays in interest? Well, he's paying $39,215.20 in interest to the total mortgage, and the total mortgage is the $131,935.20. So that ratio is 0.297, which is roughly 29.7%. I'm going to round that to 30%. Now, in a meaningful sentence, well, because this is a part to whole ratio, right? The 131,935.20 is the whole thing. Part to whole means we can write it as a percent. 30% of what Roger paid to the bank went to interest, right? That just tells you how much it is. And Roger, I mean, this relatively is not horrible, but 30% of every payment, that means every time Roger paid them $100, 30 of it went to interest, 70 of it actually went to his loan. So that just kind of gives you maybe a little bit idea of what's going on here. Okay, let's continue on with Roger. Now, we're going to kind of switch gears. Same money, same everything else, but we're going to think about this now kind of like month by month, almost like we did with credit cards. So if you remember the credit card section, let's just pretend month number 1. Roger borrowed $92,720 for 1 month with an annual interest rate. How much interest would he owe for that 1 month? So this is kind of like a finance charge on a credit card. So we would take his APR, divided by 12 to make it an MPR, right, the monthly percentage rate, and then we would multiply it by the balance, which is $92,720. That means for the first month, Roger paid $289.79 in interest, just in interest. So that's the interest for month 1. And if you actually look at an amortization table, which is like this big long thing of how much you would pay every month for a house, the beginning months are more interest than principal. But the more you pay, the more that flip-flops. And we're going to show that a little bit in a table. Okay, so remember, Roger's monthly payment was $549.73. So if he's paying $549.73, and as we just found out, $289.75 was going to interest, how much is actually, so this was going to interest, the rest goes to the balance of the loan. So when I subtract these, I get $259.98. So you can see that the interest was almost $30 more than what was going to his balance at the beginning of the loan here. So what will Roger's loan balance be? Well, he started with a balance of $92,720, and we just found that the reduction in his balance is $259.98. So at the beginning of month 2, he's going to have $92,460.02 still to pay. So if this is his new balance, will he owe as much in interest in this month? Why or why not? And the answer is no, right? Because he owes less. If you owe less, you will pay less interest. That's just how it works, which is why they always encourage you to make the biggest down payment you can, because the less you borrow, the less you're going to pay in interest. Okay, and now we're going to do kind of like that credit card table we did back in the credit card section. So we just found, doing the problems that we just did, we found that the monthly interest for this first month was $289.75. So monthly interest we're going to do in this teal color. And remember, we did the APR divided by 12 multiplied by the balance. And that gave us $289.75. Now the mortgage payment was constant. That is always going to be $549.73. $549.73. $549.73. Roger never pays more than his minimum payment, which is fine. And how did we find the decreased balance? We'll do this in yellow. That one we took the mortgage payment, $549.73, and we subtracted the monthly interest, the MOINT. So when we took 549.73 minus 289.75, we got the reduction of 259.98. So leading over, we'll do this one in light orange, the balance at the start of the month, we took the old balance minus the decreased mortgage balance. All right, we took for this example, 92,720 minus 259.98. And that gave us the 92,460.02. And so then we just do the same thing again. When we go to do the monthly balance, we would take this number here and plug it in for the balance. So 0.0375 divided by 12 times 92,460.02. And that would give us a monthly interest of 288.94. You can see it went down slightly, not a whole lot. You might want to hit pause and try this. And I'm just going to talk through the rest of it. But if you want to try it on your own first, that might not be a bad idea. Okay, to find the decreased monthly balance for this second month, we would take our mortgage payment, the $549.73, and then we would subtract the $288.94. So when I subtract these two numbers, I get $260.79. I then will take my balance, so I would take, let me get rid of this, I would take the 92,460.02 and subtract 260.79 because that's how much my balance decreased, and that gives me my starting balance of 92,199.23. I then take that balance and plug it in for this formula, and that gives me a new one of 288.12. So again, you can see my interest is going down by like 82 cents, right? Not much. I'm then going to subtract these two to get how much did it go down? 261.61. So you can see as the interest goes down slightly, the decreased mortgage balance goes up slightly by the same amount, if you will. Again, I subtract. So I take the old balance and I subtract my new decrease, and that will give me 91,937.62. Now I plug that in for the balance, and it gives me 287.31. I subtract these two and I end up with 262.42. And you could do this if it's a 30-year loan. I think Rogers was 20. 20 years, 12 months in a year, 240 months. If you did this for 240 months, you would see that slowly this is going to go down, 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 and this will continue to go up. So the more months you pay, the less interest and the more it's decreasing your balance. Now, if Roger would pay more on his mortgage payment, if he would round up even just to $550, an extra 27 cents a month, what doesn't seem like a lot, over the course of 20 years, it would make a difference in how much interest you pay. It's very interesting to see. And you can play in Excel with these formulas, and then you can kind of tinker with, if you change your payments, how much of an effect it can have. So you might want to play with that. But that's kind of our intro to mortgage payments.